Okay, so let's start about memory management. So let's say we have our CPU over here and we have our random access memory, so RAM over here, and we have our hard disk. So what happens is, let's say if I write my program, so when I write my program, let's say I write my program called P1 and the P1 has 100 lines of code. Right, so let's assume we have 100 lines of code. So what happens is when I compile my program, that program, compiled program, actually goes and stores inside my hard disk. So P1 gets stored over here. Whenever I want to run my program, what happens is a copy of this actually gets copied inside the RAM, and the CPU will say, okay, start giving me the instructions, and it'll execute line number 1, line number 2, line number 3, and stuff like that. Right. So all these, so CPU needs to know where is that program P1 and which line to execute, right? So we need the address space. Let's say the CPU is 32-bit, so the address, we can have 0 till 2 to the power 32 minus 1 addresses, right? So let's say I run my program, somehow P1 gets copied inside my RAM, and let's assume it gets copied at line 1500. Okay. And when I compile my program, let's assume that the P1 actually had 100 lines of instructions. So that becomes 1600. So my program is stored between the address of 1500 and 1600. So what happens is, wherever your program actually gets stored, that is called a base register. So the CPU needs to figure out where the program starts, and it needs to figure out where the program ends, because I don't want my program to actually run code from another program, right? So I need to actually figure out where my program starts and where it ends. So we need basically we need two registers. One is called a base register. So the base register will actually store the starting address of my program, which is, let's say, 1500. Okay. The second is I want my limit address. Limit register. So the limit register, if my program is 100 lines of code, that is 100, right? So if I want to run my program P1 and P1 says that give me, so CPU will say, okay, give me the instruction for P1 at line number 32. So what CPU will say is I want line number 32. What the operating system will figure out, where is the base address? It's at 1500. So it will add 1500 plus 32. So it'll get the line 1532. It'll first figure out, is 1532 within this limit? Is 1532 within 1500 and 1600? If it is, then it'll go there and fetch this instruction at line 1532 and give it back to the CPU. If it is not, then that means that this program, the program that I wrote, is trying to execute something which it should not be executing, so it will not give you the address. Okay, so that basically makes sure that like our program actually executes the right instructions. Wherever this program is stored, that is called a physical memory. Okay, and that's a physical memory or physical address space, because like I know that it is physically at line number 1500, at the address 1500. For CPU does not care where your physical memory is or your physical address is. What CPU will say is, I want line number 32. So CPU will deal with only the logical address space, and your operating system will convert it into a physical address, and then it will get the data back for you. Okay. So I think that part should be clear. Now the problem is, like when we write our program, at that point I need to bind an address to my particular P1, right? So I want to bind my address to either line 1500 or like wherever this thing actually gets stored. So the address binding can actually happen at 3 different times. So one is a compile time. So when you write your code or when you compile your code, at that time you know that where where your program is going to get stored. That is called the compile time. That is, the address binding happens at the time of the compile time. That is called compile time address binding. Okay. Second is load time. So in load time, what happens is that when I compile my program, the program actually does not know where in the RAM I'm going to get stored. So it generates a relocatable code. So relocatable code what relocatable code means is that, like, I don't know where I'll get stored, but wherever I get stored, like, I will assume that I'll have contiguous memory allocations, and then, like, I'll have a base register and a limit register, and you can actually address it from that time. So that is called a load time address binding. The third time is execution time. Okay, so the program actually starts getting loads inside the RAM. At that time, it gets loaded somewhere. The CPU will say, okay, give me that line of code. It will go there and get that line of code. The operating system might actually move your code based on whatever is happening inside your program. So the first time, let's say program P1 starts executing. P1 starts executing. It waits for an IO interrupt. It waits for an IO interrupt. Then what might happen is let's say it was at line number 1500. The operating system might actually move this P1 at some other location when this IO interrupt actually is finished. Then the second time when it starts executing, the same line of code might not actually be there for P1. P1 might be at the location, let's say 1800. So when it happens at the time of the execution, when the CPU wants to execute, at that time, it figures out where is my code located inside my RAM and then get that to me. So that is called execution time. Okay.